It's Advanced Math Final Review, Unit 5, numbers 1 through 26, off your final review packet. And I am open for questions. Yes.
Okay.
Same one, 8.
Yeah.
Any others or just 8? Did you guys do it last night? Or night before? Which one?
12.
4 and 12? All right, starting off with number 4. Is it the 1 over 1 plus cosine? Is that the right one? Plus 1 over 1 minus cosine? Am I on the right one?
Yeah.
All right, simplify. Okay, because I'm adding fractions, am I allowed to multiply and clear? No, only when it's a complex fraction or there's an equal sign, neither of which is going on here. So this is where I rewrite it with the common denominator. And what is my common denominator? 1 plus cosine and 1 minus cosine. Do we all agree?
Yeah.
Okay, so what will I multiply the first fraction by? Top and bottom by what?
1 minus basic.
1 minus cosine. 1 minus cosine. 1 minus cosine times 1 is simply 1 minus cosine. And what do I multiply the second fraction by? 1 plus cosine. And because there's a plus sign in the middle, I don't have to worry about distributing anything. 1 plus cosine times 1 is simply 1 plus cosine. Okay. Sorry, guys. Okay, what's going to end up happening? Cancel out. And we're left with what? 2 at the top. 2 over. What can be done at the bottom? Foil. And we want to foil because we can see that possibly is an identity. Is this a conjugate type problem where the middle terms cancel out? Because 1's plus, 1 is minus. So 1 minus what? 2 over, what's 1 minus cosine squared? It's one of your Pythagorean identities. Sine squared. And ignore the 2. What's 1 over sine squared? Cosecant squared. So 2 over sine squared is 2 cosecant squared. Questions on that one? Does it make sense? Was that my desk? Okay, number 8, 1 minus cotangent squared theta over 1 plus cotangent squared theta plus 1 over 1. Yes. Yes. All right. Any suggestions? Did I write that down properly? Any suggestions on this one? There's a few things we can think of. Anybody want to give any suggestions, advice on Unit 5, number 8?
I'll turn the 1 minus cotangent squared to 1 over sine squared. No?
So 1 minus, okay, I'm not sure what.
Change the top to 1 over sine squared.
Okay.
I don't know.
Using one of your Pythagorean identities. Is that what you're saying?
Yeah.
Okay, and then I heard what else? Common denominator. Can we quickly write, which is also a suggestion, changing everything to sine and cosine is another one. Can we review our Pythagorean identities really quick? What are they? Sine squared x or theta plus cosine squared x equals 1. What's the other one? 1 plus cotangent squared x? Yes or no?
Yeah.
Equals what? Cosecant squared x, bless you. And then tangent squared x plus 1 equals what? All right. Is there any way to change the top one to cosecant squared? No. Could we change the bottom one if we wanted to cosecant squared?
Yes.
Yes. All right. So there's a few choices we have. Change it right now, find a common denominator. Clear this one by doing the complex fraction, or clear after we do the common denominator. I'll take your suggestions. Common denominator? Yes? Okay, if we do that, do you want to change the 1 plus cotangent squared or leave it? Change it. I think I heard change it. 1 minus cotangent squared theta over, what does it change to? Cosecant squared x plus cosecant squared x over cosecant squared x. Do you agree that would give me a common denominator? 1 minus cotangent squared, and theta x, I mixed up my variables. Plus cosecant squared theta all over cosecant squared theta. What could we do at this point? Change everything to sine and cosine? Yes? 1 minus, what's cotangent? What over what?
Cosine over sine.
Thank you. Cosine squared over sine squared. Plus cosecant squared is 1 over sine squared all over 1 over sine squared. And what could we multiply everything by? I heard somebody whisper it. Sine squared. All right. That leaves me with sine squared theta minus cosine squared theta plus what? Plus 1? All over 1. Okay, suggestions from here.
Isn't that is that an identity?
Sine squared minus cosine squared.
Yeah.
This one right here? Yes?
Yeah.
Is negative cosine squared plus 1. Could I rearrange this to be negative cosine squared plus 1? Yes or no? Is this equivalent to 1 minus cosine squared? And 1 minus cosine squared is what? So I end up with sine squared plus sine squared, which is 2 sine squared. Did anybody do it differently? Get it quicker? No one's going to share?
How did
1 sine squared plus 1 sine squared is 2 sine squared. And this sine squared came from the negative cosine squared plus 1. If I were to move the cosine squared over, it would be 1 minus cosine squared equals sine squared. 1 minus cosine squared became sine squared. Or this sine squared, that one is that one. Original sine squared, that changed to sine squared. Yes? You got it, yeah. This, if I were to rearrange this right here, it would be 1 minus cosine, it would be plus 1 minus cosine squared theta. And 1 minus cosine squared theta is positive sine squared theta. All right, questions on number 8? All right, number 12. Four sine squared theta minus 4 secant squared
No,
theta.
that's not it.
Um,
It's 4 tangents.
Thank you. Thank you. Because I'm looking at that like, what is going on? Okay, 4 tan squared minus 4 secant squared. Okay, what can I factor out? Did I hear a negative 4?
Yeah.
Okay, if I factored a negative 4, that would give me positive secant squared and then minus tangent squared. Do you guys agree? If I take out a negative 4, that negative secant becomes positive and positive tangent becomes negative. And was there a reason she suggested to write it secant squared minus tangent squared? It's an identity. Secant squared, if you move this over, secant squared minus tangent squared is what? 1. So I end up with negative 4 times 1, which is simply negative 4. Turn it off.
It was, I tried to call it off, and then it like, I pressed it off, and then it takes
It's okay.
Sorry.
All right.
HCS.
What was that? Yes.
So because you pulled out a negative 4, you had to switch the tangent sequence.
You didn't have to flip it. I did, so it's positive and then a minus. But if you simply just took out the negative 4, that becomes negative tangent squared because you took out a negative. And that minus becomes positive secant squared. And I just put the positive first and the negative second, but it's not necessary. You didn't even have to take out a negative 4. You could have taken out a positive 4 and then realized what was left was tangent squared minus secant squared, which would be negative 1. And negative 1 times 4 would still be negative 4. All right. Any other questions before we wrap up Unit 5?
You said it's -1.
If we did not take out a negative 4, we just took out a positive 4. You would have positive tangent squared minus secant squared. Tangent squared minus secant squared is positive 1 or negative 1 when you move the 1 over. You tell me. Negative 1. So you'd have positive 4 times negative 1, which would still come out to be negative 4. All right. Any others from which one? 5. One plus secant, and then over tan theta plus sine theta. Yes? Okay, anyone do this one or looking at it now have any suggestions? Okay, who whispered that? Louder? Change everything to sine and cosine. So secant, good job. Secant is 1 over cosine. Tangent is sine over cosine plus sine theta over 1. All right, how do we clear this? Multiply everything by cosine. Okay, what does that leave me with? Cosine theta plus over sine theta plus sine theta cosine theta. I remember something like this, very similar, being on your Unit 5 test. It was like the second page in, And it was very, very similar, if not the same thing. Does anybody remember what you do next or can see it? Denominator, pull out a sine theta, GCF. What does that leave behind? Don't forget that 1 plus what? And what's going to happen with that and the cosine theta plus 1? Leaving me with 1 over sine. And do we leave our answer as 1 over sine? No, what is that? Cosecant theta. What was that? Number 7? Mm-hmm. 7 and 11? Okay, number 7, cosine theta, parentheses, secant squared theta minus tangent squared theta. Is that correct? All over sine theta times cosecant theta. Okay. Is the final answer cosine? Yeah? Okay. Can anybody see, like, a lot of things are just going to, like, boop, 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 disappear? What's, okay, she's saying this right here is a big fat 1. Do you guys see that? Secant squared minus tangent squared. Is that 1? All right. So I'm left with cosine theta times 1 is cosine. And what did you say? That's a reciprocal. Reciprocal functions, it equals 1 as well. So cosine theta is what you're left with. Do you guys see how that worked out? Sometimes the easy ones freak people out. They're like, oh, there must be more to it, and they make it more complicated. Take it as a gift. Sometimes there's easy problems. All right. Sine squared of pi over 7 plus 10 plus cosine squared of pi over 7. This was another one from your test. It was actually the very first problem, and it looked like this on your test. Sine squared 50 degrees plus 50 plus cosine squared of 50 degrees. And I remember because a lot of kids ask, is that supposed to have a degrees? No, it's not. These two are the degrees. This is just the number 50. These two are radians. This is just the number 10. What can I do with these? Is addition commutative where I can rearrange it? It is. Okay, and so right here, what do you see happening? Because these two angles are the same, sine squared plus cosine squared is 1. What's my final answer? Do you see why it's 11? Like over here, what would it have been? 1 plus 50, which is 51. That was number 1 on the Unit 5 test, or not those exact numbers, but very similar. Got it? Okay, we're good. Any others before we wrap it up? No, Lonnie? Is there another one? No? No?